Welcome to our NPTEL lectures on NPTEL power quality improvement technique. Today we are going to discuss about the operations and the control of the UPQC. We have discussed classification and introduction part of UPQC. Now we shall discuss about how this UPQC will work and its control strategies. So, as discussed in our previous lectures that it is a combination of the series and the shunt filters. So, at the same time the shunt compensator of the UPQC, that is D-STATCOM or shunt active power filter, may be mitigate most of the current quality problems, that is its current harmonics and also the unbalanced problem of the current and also the power factor problem of the current, such as reactive power, that is power factor, unbalanced current and the neutral current, that is for the 3-phase 4-wire system, harmonic, and if there is a fractulations kind of load like arc welding and something, then if it is present in a consumer end, this will mitigate this kind of loads. And otherwise, the system will provide a sinusoidal balanced current in the supply with DC bus voltage regulation in proper coordination with the DVR. This is the way that UPQC should work, and both are voltage source converter and uses the PWM control. I shall discuss separately the grid connected voltage source converter control therefore, and they require a small filters because switching frequency has to be around 10 kilohertz for the IGBTs. So, size of the filter is going to be very less to mitigate this switching frequency ripples in voltage as well as current. Generally, to sense the current, we have a Hall effect voltage and the current sensors, LEM kind of entities for feedback signals of, and generally nowadays we implement in the digital domain. So, it required to be fed into the ADCs. From ADCs it will go to the your DSP or the FPGA system to generate your control pulses. So, normally a digital signal processor DSP or maybe FPGA is used to implement the required control algorithm that we have discussed already, the different kind of control algorithm, that is mainly your Akagi's methods, instantaneous reactive power theory or the SRF theory is used to implement the required control algorithm to generate the getting signals for the solid state devices for both the UPQCs, for both this voltage source converter of this UPQC. The series part of it used as a DVR, as mentioned in previous class also, previous lectures, is normally controlled in PWM voltage control mode to inject the appropriate voltage in series with the AC mains to boost up the voltage, and it can inject in quadrature with the current or the in phase of the current depending on the control strategy of the UPQC. On the other hand, the shunt portion of this voltage source converter acts as a D-STATCOM and is normally controlled in PWM controlled, it is a current control voltage source inverter essentially. So, control in PWM current control mode to inject appropriate current in parallel to the load of the system. So, it is for this is called shunt. So, we have already discussed there are different kind of UPQC, that is UPQC-Q, it injects the voltage in quadrature with the current, it injects the voltage, P inject the voltage in phase with the current, and S can inject the voltage in appropriate angle or the optimal angle to compensate. So, we have already discussed this method. As mentioned earlier, the criteria can be UPQC Q, UPQC P and UPQC S. So, reference signal for the control for both the component of the UPQC have to be derived accordingly using the number of the control algorithm, and it is normally used to control the D-STATCOM and DVR. Generally, we will see later, shunt part maintains the DC-link voltage and DVR inject the voltage. And if it is a Q control mode, then SOL control does not arises, only this mode and this mode UPQC can take out power if there is a extra voltage, and then it will take out power and inject it to the DC link voltage, and from the shunt path that power will go to the system. There are more than dozens, I may be wrong, it may be as long as 20, 30 of the control algorithm that are used to control the D-STATCOM and DVR. The control algorithm are classified mostly in the two domain. One is in time domain, another is in frequency domain. So, these are the number of dominating features of the time domain algorithm. One is synchronous reference frame theory, also known as the DQ theory. It is quite popular, and this strategy we will discuss in tandem with the grid connected voltage source converter. There we shall discuss how this features has been incorporated, not only UPQC. Now generally UPQC may be connected with the your distributed generations. So, power quality as well as it has a capability to inject the real power. This is a new feature has been add on, and there we shall see that a grid connected converter, how this theory will work in detail. Thereafter, this instantaneous reactive power theory proposed by Akagi in 1984, and it is also known as the PQ theory or the alpha beta theory. So, these are theory can be extended to the single phase system. Instantaneous symmetrical component theory. So, we can split this unbalanced current into the positive and negative sequence and the 0 sequence, positive and negative sequence for the 3 phase 3 wire system, and positive negative and the 0 sequence for 3 phase 4 wire system. So, where we can find something else. So, ultimately this source has to supply the positive 0 sequence component. So, this UPQC will ensure that this negative sequence which incorporate all the unbalanced part of the it, and the ripple portion of it will be the harmonic part, will be injected by the shunt portion of the current and the series portion of the voltage, and thus other portion that is remaining, that is the balanced positive sequence component, that will be fed through this supply only. So, thus it will seems to be a resistive load connected into the system. So, there is a power balance theory also, that is called balance of power theory, rather in this I will say not power balance theory, we generally say BPT. So, here we require to balance with the average power, because you know that we have, if you multiply forget V, sin n omega t and sin m omega t, if you integrate over 0 to 2 pi, though this value will be 0, but these are ultimately only this only this dot component will survive. So, fundamental voltage, multiplication of the fundamental voltage and current will be surviving, other term if you integrate it will vanish. So, this term if you can subtract from the instantaneous power, that will be the ripple portion of the power, and that required to be fed in form of the voltage and current from this UPQC. So, this is the task of it. Now, with the advent of the soft computing technique, neural network based theory also been proposed. So, we can generate a transfer function and you can train them to minimize maybe the THD, and thus a current THD as well as the voltage THD you get this, and thus control technique can be achieved by ANN. Similarly, there is a PI based control algorithm where desealing voltage. I am going back to this whiteboard. What happened here? You have generally you have two VSC, VSC 1 and VSC 2. This is generally the shunt part and this one is generally the series part. So, here the shunt path, what happened? You have the VDC. So, VDC and you have actual VDC, and from there you will subtract the reference VDC. From there you essentially get an error, positive or the negative error, that you will feed to the PI. That PI essentially will give you a value, I say VSD, then this block will be multiplied to the unit voltage template of 120 degree phase shifted, it is sin omega t, and thereafter it can be multiplied with the sin omega t minus 120 degree and sin omega t plus 120 degree. So, you get reference ISA of t, ISB of t and ISC of t, and this you will subtract from IL and you try to inject it. So, this is the method has been based on the, this is also called the indirect method, and this has been used for controlling indirectly the this StatCon. So, this is the PI controller based algorithm. Similarly, current synchronous detection technique is another method, all require an explanation, and thereafter there is an algorithm to find it out I cos phi component, that is essentially in phase component you have a voltage and current may be a phase shifted by an angle, and ultimately you require to get the IP essentially IP cos theta or cos phi, this you require to estimate, and thus you subtract from the load current and rest of the current will be fed through the shunt active power filter for the current, and also you will calculate the same thing from the voltage. Single phase PQ theory, this is an extension of this. So, you know alpha beta transformation for ABC to alpha beta FEM or the PQ. Here you have to split it into the 90 degree out of phase for a single phase system, and you try to compensate the reactive power. And similarly, you may have an enhanced phase lock loop control based algorithm. We shall discuss about the PLL in next class, because PLL is a very important entity and it is quite important in the DQ methods and other method also. So, enhanced PLL theory, because we require to be talked about the drawback with the DQ theory. DQ theory is very much sensitive on the estimation of the this theta. If there is an error in estimation of the theta, this synchronous reference generation technique will fail, and thus to enhance the capability, and mostly it fails when there is when voltage is dirty. If voltage is cleaned up, then there is no problem. If voltage is dirty, then there is a problem, and mostly if there is a problem of the unbalanced voltage, and for this reason we employ the EPL. So, there it can be a enhanced PLL. So, while discussing PLL, we shall take out this issue in detail. Then conductance based algorithm, please understand that this when UPQC has been connected, the circuit react to behave totally resistive. Thus, impedance will be minimum and the conductance will be maximum. So, ultimately we require to do something that we require to reduce the current into the system. So, the algorithm is based on that, and we try to reduce the, since voltage is maintained constant, that is a task of the utility. If utility does not provide, then you should provide the constant voltage by the DVR, and then algorithm will ensure that you take minimum current from the source. So, this is the conductance based algorithm, and thus of course, you mitigate the other losses. An adaptive detection technique known as the adaptive reference and the cancelling theory. Mostly this is the wavelet based theory. When there is a load change, it is been detected. Based on that, we may have some kind of analysis, and we can try to evolve maybe the control loop, that is maybe the MBRAC or other method, because you try to estimate the two quantity from the two methods. One is adjustable method, another is adaptable method, and try to get the actual value of the theta. Mostly MBRAC is been used to estimate this PLL, and then it is been applied here. This is generally the technique most of the researcher follows. Now, same way we have seen the complexity of the time domain. So, there is a big challenge, your computational burden is quite more. To get rid of that computation burden, we wanted to have a control reference generation technique in frequency domain. So, simplest form is that the Fourier series theory, you can express your IL in terms of A0 if DC component is present, generally it does not present, summation of AN cos omega t cos n omega t and plus Bn sin n omega t n equal to 1 to infinity. From there, by trial and error, or maybe by ANN, by training ANN, you try to take out the roots, because you know that what kind of load is. If you know that 6n you have a 6 pulse load and nonlinear load, then your harmonic content will be 6n plus minus 1. So, you estimate that. Apart from that, and if you have from the symmetry of the data, you can calculate. So, this is the data. So, you have a odd wave symmetry, and from there you know that this will be the harmonic content, and you try to map this harmonic content accordingly. Thereafter, there can be another method, that is discrete Fourier transform theory, that is DFT. So, you get a data, all the data has been collected from the Hall sensors, is been fed to this ADC. From this ADC, the data goes to the MATLAB or any programming language domain. There, after taking data of the 2 cycles, or you may reconstruct if there is a steady state is available from this from the quarter of the cycle, you can construct the full cycle. You require 2 cycle data mainly, and so you can do the, it is called the DFT. You can have the DFT and find it out the frequency component accordingly. Same way you can do the FFT. FFT is quite popular method. So, there we can find it out the FFT. Since load is stationary, you need not have to find the FFT. When load change is detected, then you can go for the change in the data, and thus you can go for the recursive Fourier transform or sliding window Fourier transform, so that it gives you the better results. Same way we can use in a digital domain the Kalman filter based algorithm to estimate the voltage and the current component of the frequency. Another is the wavelet transformation theory that I was discussing. It is gaining popularity quite rigidly in a power system domain. So, what happens if there is a load change or the fault occurs, then based on the mother load change, there will be change in pattern can be detected easily. So, from there we can estimate the magnitude as well as the phase of the current changes, and from there we can estimate, and ultimately we generally do FFT after that to re-verify the actual data. So, one of the advantages is that wavelet, that it can detect the moment load has changed, and also it can give you the what is the amount of the load change and what is the component required to be injected. But sometimes it does not give very good data, because how well you have designed the mother wavelet, that is a challenge. This is something those who are working on the wavelet, they can appreciate it better. So, how well you have designed the wavelet based on its reference generation will be depending on, and if you have wrongly calculate the compensating voltage and current, if you are then of course you do not get the desired THD one. Another is that if you want to compensate more voltage or current, there will be a sag or swell in the system, and so the capacitor voltage either will collapse in long term or it will try to swell it up. Same way Stockwell transformations or the S transformation theory are nowadays used to the mathematical calculations. So, this is based on that we can also estimate the different parameters of the Fourier series. And same way the empirical decompositions of or transformation theory, this is also gives you the your load current component in the Fourier domain, and also this is quite familiar, it has been used in the communication engineers, and that technique can be very well be useful here. That is called Hilbert-Huang's transformation theory, and this is also can be applicable to estimate the voltage to be injected and current also to be calculated. So, let us come to the control criteria of the UPQC. There may be a number of criteria for the UPQC similar to the UPFC that is been used in the mostly in the fax devices, and that is been put into the transmission line, while which is mainly used to control the active power flow, because we deal with the power flow with the fax devices, and we are controlling the quality of the power in case of the UPQC, mainly used for the controlling the active power flow in both the directions with injections of the series with the active and the reactive power. So, there power flow is V1, V2, V3 x sin delta. So, you have to play around with these parameters, but nowadays this concept also extended in the distribution domain because of the penetration of the distribution generator, because solar inverter is ideal in night. So, why can't it acts as a UPQC in night, and even daytime it can act as a UPQC with a solar cell integrated, and that is what happen, it can also send you the balance of power, not only it mitigates the power quality. So, this features has been the add on of the power quality. that is the integration of the power quality with the distributed generation, with the injections of the series voltage with active and the reactive power. Generally, so we require to know the features of the UPFC to understand better the UPQC. Is a versatile power flow controller used for the control the active and the reactive power in all the fourth quadrant. That means you can all the fourth quadrant means power can be positive on this is a generally this is a I and this is a V. So, you can operate here, you can operate here, you can operate here, you can operate here. Voltage and voltage current can be positive with respect to the reference and the current can be in negative directions. For example, when a solar inverter is fitting back to the grid and you want to have a maximum power to be dispatched, whatever power has been generated, because grid is a infinite sink. So, all and you want the power handling capability of this grid and reduce the congestions. This can be done generally by the UPFC for the past 30 years. Now, we want to do the same thing here, since our since nowadays due to the distributed generations, sometime load becomes also a generator. So, thus we require to change the way it will operate. So, similarly, the UPQC may also control to inject the series voltage between AC mains and consumer load through a series compensator DVR at any angle from 0 to 360 degree. This is the one of the major features of UPQC. We have discussed this UPQC as UPQCQ, just recall that in this mode generally it injects the voltage in quadrature with the current. In this mode DVR is used for reactive power injections for fundamental voltage compensations. In this case, series voltage is injected in quadrature with the AC mains, current flow through the DVR and also acts as a, and no active power is required. So, power handling capability is minimum, but effectiveness is also minimum because it only inject power in the quadrature. So, we require to have a huge injection of the voltage to mitigation of the sag. Thus, rating of the switch is required to be high, though power handling capability may be low, but that is quite contradictory. If rating of the switch is high, then definitely your switches have a higher capability of the handling power. So, as told in a previous class also, DVR cannot compensate voltage swell, because always your hypotenuse will be more than your base. So, for this reason this mode of operation only preferred for the sag correction, and in this case D-STATCOM compensates the reactive power of the consumer load and the unity factor is realized at the PCC. So, now let us talk about we have discussed the classifications there. Now, let us talk about the rating of this UPQC. So, the DVR injects the voltage in quadrature in the AC mains current, and this is the voltage being injected in quadrature with the voltage in quadrature with the current, pardon me. So, ultimately this is the angle delta new angle with the current, and it was previously the Vs and this was the phi. And thus what happened in this case, the voltage sag also there is a limitations of the sag compensation depending upon the voltage rating of the DVR. So, how much you can inject, there is a limit, it can be 0.5 per unit. So, this hypotenuse can be the half of this base maybe. So, thus you have a limit of the compensation of the sag. So anyway, so voltage sag for this reason can be expressed as X, that is VLC, it is uncompensated voltage, minus VLC square minus dVr by VLC, where X represents the percentage of the sag for the compensation of the dVr is injected by the dVr, and LC is the load voltage after compensations. So, this is the calculations mitigation of the sag. So, what we can do in this case, the rated injected voltage is known from this above equations, that is fixed because you have chosen that kind of rating. It can calculate the voltage sag that can be compensated with this mode of operation. And in this case, now the D STATCOM has to supply some amount of the reactive power to meet the losses of the UPQC, but it does not supply any active power of the dVr, as the dVr does not inject any real or active power. Therefore, this method of UPQC is considered as a most conservative and provides minimum level of compensation. Thank you for your attention. I will be continuing to the different kind of UPQC in your next class. Thank you.